Hello everyone. This is a resource video about section 12.3, number 49. I found that many students were struggling with this problem. So I want to cover this one here as a resource video. Okay? So first of all, you were given this iterated integral, number 49. Yeah. Number 49, section 12.3, number 49. So iterated integral is given like this: 0, 4, square root of x2, 1 over y cubed plus 1, dy dx. Now, if you try to do this iterated integration, you don't know how to get antiderivative of 1 over y cubed plus 1 without the presence of y squared on top. So you can't use reverse chain or substitution rule here. So that's why they asked in the problem, they asked you to flip the order, switch, reverse the order. Before you reverse the order, I'm going to call this one integral I for integral. You have to recognize this is a double integral of this function over a certain region expressed by this iterated integral. Okay? This is the most important step. You have to recognize what kind of domain we are talking about. So we have to read it as it is. X runs from 0 to 4, right? You're doing some outermost when you read it. And then for given x, y runs from here to here. So it is given as what? Type 1 region. Okay? Then let's draw the region here. X is 0 to 4. And y runs 0 to 2. Now, y runs from y equals, so you go through the region through the curve y equals square root of x. Square root of x. Okay? This is y equals square root of x. So for any given y, you're going through this region through y equals 2. No, not like this. Sorry about that. For given x, let's say, for given x, so it's not this region, actually, it is this region. This is y equals 2. So this is y equals square root of x. Okay? And this is y equals 2. So given x, you enter the region. So let's say x is given here, any general x. You're going through the region through y equals square root of x. And all the way to y equals 2. Right? So this is the region. So this is interpretation of this domain D, I'm going to call it domain D, as a type 1. In order to switch, reverse the order of integration, we have to change it, we have to another type 2. Okay? Now then, this one is same as x equals y squared, right? And this one is x equals 0. So y runs, you can write in type 2. Y runs from 0 to 2. And for given y, for a given y, you're starting, enter the region through x equals 0, right? X runs from x equals 0 to y squared, right? X equals 0, x equals y squared, right? So, it turns out that the given literal integral is a double integral of the same function on this region, alright? And this one gave the description of the region in type 1. Now we rewrote it as type 2. Then, according to this analysis of type 2, we can rewrite this double integral as type 2. Y runs from 0 to 2. X runs from 0 to y squared, 1 over y cubed plus 1. Okay, this one is dy outside and dx inside. Okay, now we just solve it. So x derivative, x, antiderivative with respect to x. So this behaves just like a constant because it is about y. So that would be 1 over y cubed plus 1 as a constant times x antiderivative. X runs from 0 to y squared dy. This is just y squared minus y squared. So you will have, okay, I'm going to write it here. 0 to 2, 1 over y cubed plus 1, y squared dy. This is typical substitution or, reverse chain rule, backward chain rule. You can write it 1/3, 0 to 2, 1 over y cubed plus 1, 3y squared dy. So your inside function is y cubed plus 1, outside function is, derivative of inside functions present. Your outside function is 1 over u, and derivative is ln of y cubed plus 1. Okay? If you want, you can do this. U equals y cubed plus 1, du equals 3y squared dy. So y squared dy equals 1/3 of du. So this one will be, 1/3, 1 over u du. But then when y equals 0, u equals 1. When y equals 2, u equals none. Alright? Anyway. That will be 1/3 ln of u, absolute value from 1 to 9. Or 0 to 2, same thing. ln of 8 plus 1, 9, minus ln of 0 plus 1, this is 0. ln of 9 over 3. You're going to get the same thing. Either way. So, by reversing the order of iterative integrals, we were able to integrate this one easily. So this is a very, very important type of problems. Yet many of you seem to have trouble in understanding. So that's why I decided to give this detailed solution as a video section. It's a resource video. Okay? Alright, so I hope that this one helped you understand the problems. And similarly, you have quite a few problems like that. Alright? So I want you to go over those problems again. These are very important problems for any quiz or exam. Okay? All right. Thank you and see you next time.